Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question in the premium category that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is question 2277, closest node to path in tree. So you're given a positive integer n and sort of this subgraph. So what's going to happen is you want to basically build this tree, and then for each query, you're going to return a list the same size of the query. And basically going from the start to the destination, find a node in that path that in terms of the distance is closest to this node, and then return that node for that particular value and put it into a list and return it. So notice here that it says there's a bidirectional edge connecting node 1 and 2. So that means 0 can go to 1 and 1 can also go to 0. So let's first build the graph. And let's go for source, destination, and edges. D of source, dot append destination, destination, dot append source. And then now we can basically just go for the source, destination, and, or let's call this start and end and node and query, just to be consistent, as it says right there. And basically what we're going to do is go from the start to the end, okay? Let's not first worry about any optimization. Let's just get every node from the start to the end in the tree that we built. So let's call this total, and let's make a queue. Again, we're starting with the start node, and we're going to basically contain all the nodes and then go from start to end, okay? So while queue is not empty, again, the total and the node, or let's call this C node so we don't interfere with this. We're just going to pop left, exactly the order that we put it in. So first in, first out, or last in. So we're going to be appending to this queue, and then we're going to be popping from the left. So basically doing it in line, right? So the last in is the first out. And then we're going to have a set called scene. And basically, if C node is in scene, then we continue. Don't want infinite loops. We're going to add the current node. And then we're going to explore each of its neighbors to find, hopefully, the end node, right? We're starting with start, and we want to get to the end node. So basically here, we're just going to append. And what we're going to do is take our current total list, and we're going to add the neighbor to it, and then that's just the neighbor node. And at any point, if C node is equal to the end node, then let's print the total, and let's go ahead and break it, right? Because we've reached the destination that we've wanted to. So, okay, so it's not letting me do that. Let's make this a deck. And then let's append start and start. Okay, so it doesn't look correct because doesn't seem to be any nodes. So, yep, basically we just want to keep getting all the nodes in that path from start to end. So I'm not sure why this is not showing up. Let's try that. That's still not showing up. Let's go ahead and print total and C node here. Okay, so it does look like there are some nodes showing up. Let's call this new total is total plus our neighbor, and then new total. So it still doesn't look to be showing up. because we're starting with the start and this has to be the end, right? So let's go ahead and try to figure out what's going on. So we're appending here and then we're just popping there, appending this new list here. Yep, so 5. Why are we going to 1? So something is wrong here. We're trying to append source to destination, right? Destination to source. And then we're just starting from the start. So let's see here. Yep, we're going to append that, and then we're going to take the neighbor. Looks correct to me. Perhaps we actually do not need this here because we're going to be breaking anyways. Oh, nope, we do need that. So just a thought, because we're seeing 0 that's not here. So 5 and 5, 1. Not sure what's going on. Let's print our queue. Yep, we're trying to get to 3, but it doesn't seem like we're at 3. Because the node is never 3. So yeah, we never get to 3. That is very odd. Trying to explore. Oh, small bug there, right? C node instead of node. Okay, cool. 5203, 5203. Perfect. So now what we can do is for each element, bring back the container to hold all of them. Because that's only those nodes are in the path from 5 to 3 in the first example, right? Okay. So now that we have that, and we're going from 5 to 3 twice, right? Trying to find the closest one to 4 and the closest one to 6. So what we're going to do is start again. And basically this time we are going to start at the destination, right? The one we're trying to find, the node number that has the closest distance to this query node's last index. So basically, we're going to append query of -1, which is just the target. And we're going to start there. And this time we actually do care about the destination. So again, if we're starting at 4, we're just going to say, okay, 1 is of 1 distance, 0 is of distance 2. And that's the first and closest node in this path. So that's why we built this path list. So now run the same DFS again, and this time we do care about the distance. We're trying to minimize that, right? The smallest distance, the closest node. So now let's call this the distance, and the actual, let's call this C node again. We don't care about this anymore. We're going to heap pop from the queue to sort by this, and then we're going to create the scene set again. If C node in scene, again, continue. And then for neighbor in D of C node, again, we're going to heap push into queue this time. And we're going to push the distance +1 because every edge is takes another moment or count to reach, right? And then we're going to push the neighbor on there. So at any point, if the current node is inside of total, then let's print the actual distance and the C node because we're looking for the closest distance in that path. So we're trying to heapify this. We don't need a queue anymore, a doubly ended linked list. So the C node here is just supposed to be query of -1. Cannot use list. We're just looking for that node. Okay, I'm not sure what's going on here. Oh, this time it's just supposed to be the node, right? So we accidentally put the whole list in there when we did not need to. Okay. Oh, add C node, prevent infinite loop. Okay, perfect. Now let's keep track of all the nodes in the path and their destinations, or their distances, right? And then let's print the sorted list at the end. So you can see now, node 0 is the closest, node 2 is the closest, because this is the closest of all the distances, and we're only including all the nodes that were in the path from the start to the end, right? Cool. So now we can just get what we need from the sorted list, and we're just going to append SL of 0, the closest distance, and the node itself instead of the distance. So 0 and 2. Cool. And then at the end, we can just return our answer. So let's run this, submit it. Okay. Oh, time limit exceeded. Not sure what's going on there. Okay, let's try to optimize this. And if we're in the total and we're doing this, why don't we just break it? Because do we really need all of the other computations, right? Okay, so let's submit it again. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. And again, this is question 2277, closest node to path and tree. This is a hard question in the premium section.